Let's say we've set up a VLAN access control list in our environment, and traffic is not being filtered properly as we intended it to. We can verify this simply by trying to access those resources or services that are being permitted or denied within that particular VLAN access map. So ping is useful, but we might have to try some other services. For example, we might have to use a web browser in order to verify whether connectivity via port 80 is working or not. It's depending on what that VLAN access control list is filtering, or even telnet. Telnet to port 23 or telnet to port 80. So change the port numbers to verify if you have connectivity to that particular service based on that port number. So how can we investigate what's going on with our VLAN access control list? Well, as we've mentioned before, let me try this again. Let's say you set up a VLAN access control list, but you're not getting the results you intended. The filtering is not happening as you had envisioned. What are the reasons that could have happened? Well, you're going to be dealing with access control lists. You'll be dealing with the VLAN access map itself. And then you'll be dealing with the VLAN filter that is applying the access map to particular VLANs. So you'll have to verify access control lists using the show access list command, making sure that the access list has been configured correctly. If not, modify it. In order to verify the VLAN access map and see if it's been created successfully, you're going to use the show VLAN access map command. However, the command is not available on all devices. For example, I have a 2960 Catalyst switch, and this command does not exist. Even though you can create VLAN access control lists and VLAN access maps, you cannot verify them with this command. Therefore, you have to use the running configuration to verify that VLAN access map. So keep that in mind. Even though you can configure it, this command might not be available. You'll have to use the running config in that particular case. And if you do see an issue with the VLAN access map, then you're going to have to modify the VLAN access map so that it's correct. But maybe you verified the ACL, it's fine. You verified the access map, it's fine. What else could be the issue? Well, did you apply it properly? You apply VLAN access maps to VLANs to filter the traffic, and you do that with the show VLAN filter command. So if the VLAN filter command was not set up properly, you'll have to remove the current VLAN filter and then apply the correct VLAN filter that is specifying the correct VLANs that the access map is applying to. Let's examine a VLAN access control list issue within our topology. So this is related to VLAN 10. We are trying to prevent PC1 from being able to telnet to PC3. However, it should be able to do everything else, including ping. But if we issue a ping right now, 10.1.1.30, we'll see that the ping fails. So PC1 is not able to ping to PC3 when it should be able to. So let's start our troubleshooting by analyzing all of the information that is required within a VLAN access map on DSW1. So we access DSW1. We know we have a VLAN access map. So let's type in show VLAN access map. And we'll see from this output that the VLAN access map is called TSHOOT. It's got a sequence number of 10. And it's saying match IP address 100. So let's look at access list 100. In the output of show access list 100, we'll see that we are permitting TCP from 10.1.1.10 to 10.1.1.30 equal to telnet. Now you might be saying, oh, well, there's the problem. You're saying permit. It should be denied. No, hang on a second. The access control list here is a classification access control list. What we are doing is we are identifying that if traffic matches this, we want to perform a specific action on that traffic. So we're going to permit this, saying that, yes, we want to perform an action on this traffic. And what is that action? That action is to drop the traffic. And if you recall from our scenario, the scenario was we want to prevent PC1 from telnetting to PC3. So we can see here that we are saying if PC1 tries to telnet to PC3, drop the traffic. Perfect. It is doing what it's supposed to do. So was it applied correctly? Show VLAN filter. Show VLAN filter says that the TSHOOT VLAN access map is applied to VLAN 10. So, if PC1 tries to telnet to PC3, drop it. And it's applied to VLAN 10. Great. What's the problem then? What did we do wrong? Well, our issue is related to the processing of a VLAN access map. VLAN access maps are processed from top down in order of sequence. So sequence 10 right now is saying drop all traffic from PC1 to PC2 related to telnet. That's what it's stating. So sequence 10 would be checked first. And then if there was a sequence 20, 30, 40, 50, 60, whatever, any sequence number, it'd be processed in order from lowest to highest. But what if your traffic doesn't match a sequence number that exists? For example, does ping traffic match sequence 10 here? No, it doesn't. Because the access control list for sequence 10 is talking about telnet. And it's dropping telnet traffic. So what happens to the ping traffic? What happens to the HTTP traffic? What happens to the SSH traffic, etc., etc.? Well, it falls into the invisible. That's right, I said invisible. It falls into the invisible sequence that you cannot see here. You know how an access control list at the very end has an implicit deny all? You know how route maps have the implicit deny all sequence at the end? Well, VLAN access maps have the implicit deny all sequence at the end here. And what does the implicit deny all sequence have as an action? The action is to drop. So you can't see it here, but it exists, and it's going to drop everything else. So the issue in this case is the fact that we forgot to add a sequence that would permit everything else. Permit everything else. So technically speaking, we're dropping all other traffic in VLAN 10 right now. That's what we're doing. All right, so let's create another sequence. So VLAN access map, it's called TSHOOT, and let's give it a sequence number of 100 in case we have to add other sequences in between 10 and 100, just to give us some room to add things in. And our action is going to be forward. Now notice I didn't put a match clause. We don't need a match clause here because without a match clause, it means match absolutely everything. And that's what we want to do. We want to forward everything else. So now let's review the output of our access map. It says we have a sequence number of 10 that matches IP address 100. So access list 100, action drop. And then sequence number 100 says to forward everything else. Forward everything else. And just to show you again, show VLAN filter is saying that this is being applied to VLAN 10. So let's go back now to PC1. Let's try our ping, and it works. What about ping in the default gateway? Can we get to the default gateway? Yes, we can. Why? Because this traffic's being allowed now. A while ago, we were denying everything. That's what we were doing, denying absolutely everything. But here's the real test. Is telnet still denied? This is the true test right here. And it is. We still can't telnet to PC3. And that was our goal. Deny telnet, but allow everything else. So just to recap, what do you want to be aware of when you are troubleshooting issues with VLAN access maps? Double check the access control list with the show access list command. Double check the VLAN access map with the show VLAN access map command. If this command is not supported on the device, just use the running configuration show run. Pipe to section access map would take care of that for you. And then double check to make sure that the VLAN filter, so this access map, is appropriately mapped to the correct VLANs with the show VLAN filter command.